Trig yourself before you electrocute yourself.
By Kate Lynott and
Samuel Hanzelka.
Trigonometry History. Trig is the study of the relationship of angles and side lengths of a triangle. Dating back to many years, the concept of trig started with astronomers noticing that the side lengths of a right triangle held a correlation to the angles of a right triangle. Important people. Ben Franklin conducted the kite experiment. There was a key attached to the end of the kite on a stormy night which created electricity when struck by lightning. Hans Christian Ørsted discovered that electrical currents create a magnetic field. Nikola Tesla worked with AC currents and DC currents and discovered that AC currents travel over a larger distance than DC currents.
Electricity. Although it may be an old concept at this time, it's still ever evolving and improving. It all started with a strike of lightning on a kite that woke up the world to such a power. In 1882, the first power station was erected and turned on. It output 110 volts of DC current, which nowadays has since been replaced with AC current, allowing the electricity to travel further than it ever has, which is where trig partially plays into electricity. Trig and electricity? Almost all power companies send out power via AC current over long distances. AC power basically means that with voltage spikes, they are creating a sine waveform which regularly reverses the direction to safely and reliably supply power to many homes and businesses.
Currents. Electricity can come in a couple forms. You have alternating current and direct current. Each has their own benefits. AC current. Polarity varies over time, but does so in a specific manner, a sine wave. Used to travel long distances because it generates less heat and resistance. DC current. Supplies a constant amount of voltage or current, no fluctuations or variations, just straight electricity. Converted at the plug to be used by different appliances, phones, and much more.
Here are a couple images of different currents. On the left you see the sine wave of a AC current. We have the equation there, y equals 120 being the voltage, sine theta. That is your AC sine wave for typical home appliances. DC current over on the right is expressed with that direct line showing a straight path of electricity, no fluctuation as shown with the green alternating current along with it.
How does it get to my outlets? AC current is represented as a sine wave, but it's used to transmit power to homes because it can supply high voltage efficiently with little resistance, due to heat making this more of a justifiable option. Before it reaches your humble abode, it goes through a transformer which converts the electricity to a lower voltage for average home and commercial uses.
Continued. AC current uses sine waves to transmit high voltage across power lines efficiently. Its wave is then decreased or increased at transformers near your home to supply safe, usable form of electricity to your outlets. An understanding of the wave's size and specifications is needed in order to properly adjust the electricity at the transformers.
So, types of people who excel at these concepts: electrical engineers. They understand powers, roots, basic algebra, Ohm's law, vectors, and basic trigonometry to do the calculations required. They use trigonometry to model the flow of electricity through the use of sine functions. And engineers in general also excel at this concept. They use trigonometry to calculate the height of support cables, height of support towers, and the angle between the two to help build bridges.
Here are all our sources used in this presentation. Thank you for joining us.